guys, there's a few things I'd like to go through with you on the review packet that I didn't get to go through in class today, and I've realized they are important for the exam. That's why I'm making this short video. The first one is this question, the first question with the waves section on the electromagnetic spectrum. It says, name 3 ways that waves change as one moves from the left to the right of the electromagnetic spectrum. So on the left you can see we have longer wavelengths, like radio waves are very long. And then on the right hand side you have short wavelengths. Gamma rays are the shortest. So we could say wavelength decreases. But wavelength is connected to frequency. When you have waves that are long, less waves pass a point every second. That means the frequency is low. But when waves are very short, like gamma rays, more waves pass a point every second. And that applies to all the waves. As you move through the visible spectrum, as you go from red all the way to violet, that same thing's happening. The wavelength is getting shorter and the frequency is getting higher. So the next thing we can say is frequency increases, and frequency is connected to energy. So gamma rays carry the most energy, radio waves carry the least, red light carries the least energy, and violet light carries the most. So as you go from the left to the right, energy increases. Because frequency and energy are directly connected. When the frequency is high, the energy is high. Okay, and then the section on electricity and magnetism. I'm going to do number 1 here, where we've got to build a circuit and then we've got to do a calculation. So our circuit is going to have a 12-volt battery, and we can just represent it like this. It's going to have one conducting wire. You might think, well, how can you have one conducting wire? Well, there it is. We have an open switch. We have a light bulb. We have a resistor. We can draw like that. And I'm going to go ahead and draw in another wire over here. So we've got 2 conducting wires, but it doesn't matter because that's going to help us to illustrate how to work this out. So it says you've got to show the direction of the current. So the current flows from negative to positive, so we can just use arrows to show that. And obviously the current is only going to flow when we close the switch. So there's a closed switch. Right, so the question, that's what I really want to answer with you guys, because in your exam you're going to get a question very similar to this. If the total resistance of the circuit is 4 ohms, calculate the current in the circuit using Ohm's law. In your reference table, which you should have out when you take the exam, we have got an equation which is V equals IR. That's the Ohm's law equation. So first thing we're going to do is we're going to write the equation down, V equals IR, and then we're just simply going to substitute. So the V they gave us, it was 12. The R is 4 ohms, okay? And the I is what we want to work out. The current is what we want to work out. Let me change the color of it here. So if I'm going to figure out what I is, I've got to take the 12 and divide it by 4. Okay? Because mathematically, I'm going to divide both sides by 4 to cancel the 4's on this side. So 12 divided by 4 is 3. So I is going to be equal to 3 amperes. And that's how you would work out the current using Ohm's law when you're dealing with a circuit like that. I also want to go over this question about an electromagnet. Explain what an electromagnet is in your own words, and what 3 things can you do to the electromagnet to get the magnetic field strength to increase. So an electromagnet usually has a core that's made of iron. So let's say we've got an iron nail, and what we do is we wrap loops of wire around that nail, and then you connect it to an energy source like a battery. And when you do that, electric current flows through these wires. You can make this magnetic field stronger by, first of all, adding iron to the core, like so, putting more nails inside there. You can add loops of wire to that core. So if this electromagnet had more loops of wire, that magnetic field is going to get stronger. And we could also add another battery. So three things. You can make the voltage go up, that's by adding another battery. You can add turns, which are the loops around the nail, and you can add iron. And when you do all of those things, the electromagnetic field gets stronger. The word electromagnet has got two parts to it. Okay, we've got electro and we've got magnet. So we're using electricity to make a magnetic field.